Hey, this is OXDF. Today I'm looking at Advent of Code 2022, Day 20, Grove Positioning System. So we're going to get a file, and it's going to be encrypted data. And basically, we're going to do this process called mixing. And basically, what we're going to do is we're going to take this list, and if we were to apply mixing to this one, we would move, because it's a value one, we move it one forward in the list. So it would jump over here. So we have 4, 5, 6, 7, 1, 8, 9, just like you see here. When you move the -2, you go back. So you go one spot before the 4, then one spot before the 9, like they show. So it's a circular list. The real trick here, and the part that makes this frankly hard at all, is that we move them in the order they originally appear. So if this will be our example input, and we'll probably use this because it's kind of tricky, and I just want to make sure we get it right. Our initial arrangement is this: we move the 1 forward 1. That makes perfect sense. Now the next thing we move is the 2. Now, again, that we're back at the front, so maybe that's fine. So we move the 2 over here. Now we move the -3 because that was the third thing in our list. Then we're going to move the 3, then we're going to move the -2, etc. The challenge is, and they don't show it in this example, but I believe we can have repeated, if we don't have repeated values, then this is not that hard. We can track it from the start. It shouldn't be that hard either way, but we want to look for repeated values, because if there's 2 1s, we can't just find the first one and move it. That'll mess us up. So after we mix the whole list, mix your entire encrypted file exactly once. What is the sum of the 3 numbers? So it's basically find the value 0. So presumably it's only going to be 1 0. Wrap it, and then wrapping as necessary, find the 1000th, 2000th, and 3000th numbers after it, and add those together. So let's go ahead and jump in. Let's see. We'll do a gen day on day 20. This script is in my repo. You can check out the link in the description. Also, I went over it in the first day video in detail, but really it just pulls me the input and a nice stub to work with here. Looking at the input, we want to take a minute and evaluate what's going on here. We have numbers. We have numbers going from, it looks like we have exactly 5,000 numbers. If we start on line 1, yeah. They range in size. I'm seeing things greater than 5,000. So we might want to consider, if we're moving something by if we had a list that was 5 long and we're going to move something 40 spots, well, we could use modular arithmetic to make sure we don't move it, if we only need to move, I don't know, move it fewer spots. Every move is going to be somewhere between 0 and 4. So we'll look at that in detail. Let's see, we can check and see if we had repeats. Sort minus uniq minus c, sort minus nr, and I should just do minus n. And so yeah, there's 7 copies of 9,935. There's 6 copies of 881. So we can't just use that number as a way to look it up. We're gonna have to track our original locations ourselves. Okay, I think we got enough to start programming. Let's see, so we can do let's see, we want to come here and do, let's call this nums, and we're going to read the lines. For each line, we're going to map int onto that line to turn it into an integer, and then we're going to turn it back into a list here. Now the way I'm going to approach this is I'm going to use a queue structure, a deque structure. Because it's just gonna make it a lot faster to move. It's optimized for moving things around, popping and pushing, versus a true Python list. So I don't think it would be that much slower if we used a list, but I'm just getting in the habit of using these kind of more optimized data structures. So what we're gonna want here is we have our nums. If we do enumerate nums, that is going to return a list of tuples. In fact, we'll check it out. So if we did lists, enumerate, well, actually, we can do deque. So we call this num. Let's make this numbers. We can make this nums equals, and then we need to do numbers. Okay, and we can check out. Let's just right nums. So if we run this, let's see, Python day input. It's kind of hard to see. You can see here at the end. So the first value is our is like our position in the thing. So there's 4,993, 994, 4,995, etc. And then the second value is the value of that position. I'm going to go ahead and grab, I think this one's complicated enough that I'm just going to want to work, I'm going to want to check my work as I go, and let's just do it here with the example input. Ooh, that's ugly. Let's save this, close this, save this, and I don't move E. Ooh, what did I do here? Okay, move E C E X T X T. Okay, that will just bother me. So now if we do a Python A20 example, we can see we get our queue here, where if our example was split right, move you over here, so we have you. If our example was 1, 2, so we see the 1, the 2, the -3, the -3, but we also have their original positions so we can walk through those. Okay, so now we're going to do a for I in range, and we're going to need to know the length of this, and we're going to need it a lot. So let's just do like len nums equals len nums. Very creative, I know. Len nums, like that. Ooh, I don't like it. We're going to need an underscore in there. It's ugly. Okay, so for I in range len nums, the first thing we need to do is find our spot. And really what I want to do is I want to get it to the front of the queue because it's going to be the easiest to deal with. So what we're going to do is we're going to say while true, if, no, okay, if nums sub 0, so the first thing there, sub 1 to get the value itself. Oh, nope, sub 0. Because we want the index. So we're looking, this I is going to be the number, like what number are we dealing with? So we're going to get the number 0, then we're going to get this 1, then we're going to get this 2. And right now those are in order, but as we mix them up, they're not going to be. So if the first one's number value equals I, so if we found our number, we will break. Otherwise, I guess we don't even need the else because we're breaking. Otherwise, what we're going to do is we're going to nums.pop left, so remove the first item, and we're going to nums.append it. And so what we've effectively just done is, if we pop this value off, and then we appended it to the end here, and so now we'll have a new front. And so when we do this, let's see, we can print nums. So if we run this now in the example, make this a little bit bigger, we're always going to have the I we're looking for at the front of the queue. So at the first, we have the 0, the 1, the 2. So as we loop over the numbers, we're going to get the thing we're going to be moving around to the front. Okay, so now we need to make that swap. So how are we going to swap this? We'll say cur equals nums dot pop left. So we now have pulled that one off the queue. It no longer exists in the queue. And now we need to think about, like, we'll do like rotate by, and that's going to be the number of spaces. So cur sub 1, like the value here. And we're going to take that and we're going to do it mod the we're going to modularize that because we don't want to we talked about this earlier, like if I need to do, this list is 1 2 3 4 5 6 7 long. If I needed to move something 10 spaces, now I don't in this case, but I might, you know, if I pick up this first one, let's say I was going to move it 10 spaces. Well, so it would go 1 2 3 4 5 6, puts me back at the beginning of the list. This is no longer here. 7 8 9 10. So it's going to be before, you know, the -2 and the 0. Well, the list, once we remove the first one, the list is going to be 1 2 3 4 5 6 long. So we can take that 10 mod 6, which is going to be 4, and we can move it 1 2 3 4 and get to the same spot. And so we want to avoid having to move. We're not, this is a slight optimization, but it's going to be valuable. So we're going to do len nums -1. So we're going to do it by, the reason we're doing len nums -1 is because once we remove the first item from the list, now that's the length of the list that's left, and that's what we'll do. And that was not the right place to put that. Put it here. Okay, so now we've got the amount that we want to rotate it by. So we'll just do for I in range rotate by, And we will just do our exact same thing again, right? We're just going to do this rotating. We're going to rotate again. And then once we're done, we can really add it to we've got the spot we want at the front. And we can add to the front or the end. It doesn't matter. So we can do nums dot append. We'll say append. Well, let's say append because it's easier. Cur. And that should add it back in. And I think that's basically, we've just done our mix. Let's run it on the example and see. If we up this here, we can see, let's grab their examples here. I wonder if I can make this fit. Let's do one thing here. When we print, instead of printing the whole thing, print nums, we'll do x for x in nums. That's just going to print the same thing, but now we'll print x of 1, and that should give us just the numbers, not the positions. It would be a little bit easier to compare. So after the initial arrangement, we don't print that. After the initial arrangement, we have 2, 1, negative 3, 3. Now we see this up here, but we can see, oh, we don't have, I don't think we've got it. Oh yeah, sorry, here, 2, 1, negative 3, 3, 2. So that was right. The next one, we're going to have 1, negative 3, 2, 3. So that'll start here, 1, negative 3, 2, 3, and that looks good. Then we're going to have 1, 2, 3, negative 2, negative 3. 1, 2, 3, negative 2, negative 3. So this is looking like it's working in conclusion. Let's put this down. So let's see. We've got that. Now we just need to calculate an answer off of it, I guess. And we can run this as our input just to make sure we've got a working solution here. Probably should remove that print. That print is going to take all of the time. Let's make sure it doesn't take too long to run. Not too bad. We printed all of nums here because that's not what we wanted, but we can, okay, so now we need to get an answer. So they told us to get the 1,000, 2,000, and 3,000. So we're going to say C for C in 1,000, 2,000, 3,000. I guess, I don't know if it's better. Well, no, that's fine. We're going to go. I was going to say we could do like a range here, but that seems unnecessary. Okay, so we have the C for that. We don't want to C. What we want to do, I wonder if it's worth actually rotating ourselves so we get our we gotta find our 0 position. Okay, we do have to find our 0 position. So we'll do it for I in range. Actually, we don't even need this I for in range. In fact, we don't even need the for. We can just do while true. We can do while nums sub 0 sub 1 to get the value is not equal to 0. And we will do our exact same rotation here. So there. And now our first item is 0. Good. So now we just need the ones after it, right? So now we can do nums of C mod len nums like that. And we can sum that. I'm going to say part 1 equals. I think that is going to work. Give it a try with our example. Ooh, unsupported type T. So this is going to get the correct item. We need to get the value, not the index. So we get 3, which is the example, which is the input they gave us. And we get 7,153. Let's go check that out. Got it. Part 2. First, you need to apply I'll pause while I read. Okay. So all we're going to do now is apply a decryption key to the start multiply each number in there by this key. So effectively what this is going to do is we're going to solve the problem the same way. We just need to make the numbers way bigger. Now this is where we're already doing this. This mod is going to save. I mean, I think the first part, in fact, we can check this. Let's see. If we do this and comment this out, and we do time, look at just our part 1 solution. It took 1.3 seconds. If we put this in and run it, takes 2 seconds, even longer. That's interesting. The mods that are taking it longer. So it's not helping us here. It's not making any difference. But when we start having to move by thousands more, like hundreds of thousands of times more, this is going to save us for sure. Otherwise, it would not be scalable. So let's see. What's the best way to implement this? I could take. We probably should create a function. So we'll do def mix, and it's going to take a q. Oh, it's going to take nums. Let's just keep the variable names the same, and it's going to take a scale factor equals 1. And so we're going to take, I guess we'll pass in fact, let's just pass in, no, we need to pass it a q because we're going to run it more than once. So we'll pass it this. Do there. This part right here is where we're going to mix. So we'll paste this in here, and we will tab this all over. Okay, so we're going to pass in a nums and a scale factor. We're going to take all of this, and then we're going to, after we mix it once, return nums. So if we do that, we don't use scale factor yet, but that's okay. We can get rid of this. So we can say nums equals mix nums. And if this all works, we should have the same answer here. Yep, that worked. Okay. Now we need to multiply by our scale factor. So, oh, we don't even need to do that right away though. So we can actually don't include that here. We could do, so this will just be part 1. We make this part that. Let's go ahead and get a score here. This like a score function as well. Def score nums takes in nums, and so we're gonna do that, and we're going to not have part 1. We'll just say return. Okay, so now we can come down here. Get nums, we mix nums, we say part 1 equals score nums on nums, and we should still have part 1 solved. Ooh, let's see, len nums is not defined. I'm not sure we actually need, we could probably just, since we're only calling it once, but anyway, we'll just do that. And we got our answer. So we've still solved part 1, but we solved part 1 now in a functional way. So we can now come down here to part 2 and say nums 2 equals deque on enumerate numbers. But we're not gonna, it's not gonna be quite that simple, right? Let's see. So we're gonna do, I guess we can do it. Generators are okay. We can do that. We can do I comma n for I comma n in enumerate numbers. So now we've got that. And the resulting thing is going to be a tuple still, but it's going to be n times this. All right, so now we're going to say, we're going to mix 10 times. So for this in range 10, nums 2 equals mix nums 2. And then we will say part 2 equals score nums 2. And we might be done. Let's see if that runs. It's going to take longer, but probably not, you know, like at least 10 times as long. Probably should take 10 times as long. So like 12 seconds, 13 seconds. It should not take like infinitely longer because we're not moving things any further because of the mod. There we go. We got a much bigger number. Give it a try. Nice. Much easier than yesterday. Hey, sorry for the kind of rough cut there. I remember there was one thing I wanted to talk about, and that was just showing the importance of making this mod here. Now, I think in the earlier in the video, I think I actually removed this and like ran it and showed how it didn't actually change the time. What I didn't check is I don't think it actually gives the right value, but we'll play with that. So what I'm gonna do real quick is I'm gonna come here, I'm gonna put a print. I'm gonna do a little bit fancy here and do this /r will move us back to the front of the line, and then we can do. I guess I should make this. I guess should make this no longer an underscore. Make this an I. Make that an I. Like that, and then we can do end equals there. And so this will do is kind of give us a running list of which iteration we're on. And then we would want to just right here do that. So now if we run this again, you can see down at the bottom now it's showing us which we're mixing 10 times. So we've done mix 3, mix 4, mix 5, etc. Yeah, we're showing it before we mix. So it's the mix we're working on. Working on 9 and we're done. Okay. So nice, just for help us track that. If I come up here and the problem, so I can comment this out, and for the sake of just showing how much longer it's going to take, this will be fine. But when I come to what am I, it's going to actually have the wrong answer, because if the number is negative, then it's actually going to, when it goes for a range of negative number, it's just going to do nothing. So that's actually not super useful. But we could do something like check if it's negative, and if so, add the full length to it so that we get back. We could also do a rotate the other way by popping and appending left if it's negative or something like that. All these things seem more complicated than just doing a mod, which is what we did in the first place. But just to show you, again, this won't be the right answer, but just to show you how much longer it takes. If I save, we can see here we're starting 0, and it's going to run for a while, and it's not going to, I don't know if you can hear my computer in the background, like all revved up and going. It is working very hard, and it's going to take a long time. And again, that's because I'm doing hundreds of thousands of rotations in cases where, my list is only 5,000 long. So I could, 95% of that work is not necessary. So I just wanted to show the increase in speed here, or I guess decrease in speed. Again, this won't quite produce the right number. I'd have to modify it a little bit. But again, I'm trying to make it worse here. So I think I've proved the point. Thanks for hanging out with me today. I will be back with another one of these tomorrow, hopefully.